This is AP Precalculus, the review for the AP test. This is called 3-Peat E. Remember that now we have calculators that are active. We don't have 1 minute and 57 seconds per question like we did with the non-calculator, but we have 2 minutes and 5 seconds, but it's basically the same thing. You have 12 questions that are going to be in 25 minutes, so a little over 2 minutes per question. You're going fast on these. So in number 1, we have these two functions, and we're trying to find the zeros when we add the two functions together. This is purely a calculator question. We're going to go to the y equals on the top left of our calculator. Ooh, I have some stuff in here, so I'm going to hit second plus 712, and that will reset my calculator. Now if I go back to my y equals, I have a clean slate. I can type in 3x minus 2.5 for my first equation, and my 1.4x squared minus 4.2x and minus 11. And then for my third function, I'm going to add those together. So the way I do that is I hit alpha trace y1 plus alpha trace y2. I can't just hit 2. I have to scroll over and hit enter on this calculator. And then I'm going to turn off these functions up here by hovering over the equal to sign and hitting enter. And I need to figure out what my window should be. So if I go to my window and I'm looking at my multiple choice options, I'm seeing in my multiple choice options, the farthest left I go is this negative 2.7. So I'm going to say my x-min is about negative 3. And for my x-max, the farthest right that I can go is about 6. So I'm just going to make this 7. And then I'm going to hit zoom 0 and see what happens. I apparently have an x-intercept a little bit to the left of negative 2. So a little bit left of negative 2 out of all these options is right there. And I can see that on this graph, a little bit to the right of 3 is about 3.5. So just eyeballing it, it looks like option C. But if you really want to get specific data, just teaching you how to go above and beyond with this calculator, you can hit second trace, and then you can calculate a 0 by hitting 2. My left boundary, let's go ahead and say I'm trying to calculate that farthest left point. It's about negative 2.7-ish. I'm going to say my left boundary is negative 3. I hit enter. And my right boundary, I'm going to say, is negative 2. And then usually on your calculator, it'll ask you to take a guess, and you could guess like negative 2.5. And you can see mine is negative 2.706, just like the answer that I have right here. I'm not going to do the second one because it's the same process. Number 2, we have this periodic function, and we're trying to find what its period is. So we can just graph this thing and kind of eyeball it, right? So if I go y equals, I'm going to clear out of all of these. Let's come down here and type in everything that we see. Sine of 2.6x and plus 2 cosine of 0.8x, and I hit what is my window going to be? Well, it looks like my options range between 7 at the lower end and 31 at the higher end. So I'm going to go from 0 all the way to the higher end to 32ish. So I'll say my x-min is 0 and my x-max is 32, and my zoom to fit, my zoom 0 has not been working on this calculator, but I'm going to try it again. I don't know why it doesn't zoom in correctly. Let's change my window here from 0-ish to, I'm going to guess like 10-ish and graph that. That didn't work. Window, let's change this to like a 5 and clear this, do like a negative 5 and graph that. Okay, so this is a little bit easier for me to see. I don't know why it's going so far to the left, but it appears that I have these really large humps at the very top of my graph, every 7-ish, just eyeballing it. So again, eyeballing, that's a 7 number, so looks good to me. If I can, here, I can annotate this a little bit. If I go and screenshot, and I can grab that, and I can save, I can just copy this, done. Delete screenshot. You can throw it in here and say, this is what I was seeing. I can actually draw on this. So on my calculator, I was seeing that this hump and this hump were this distance apart. I know that in between 5 and 10 is about 7, and this was basically 0. So I'm just kind of guesstimating between here and here is about 7-ish, and that's why I did that. I don't think it's 9, because if it was 9, then I would have gone from here. Another 9 from here is about 10-ish, and I would have had another hump right about there, and I didn't. So it's not that, and it's not any of these, but I can clearly see oh, is it a repeating pattern? Maybe not, because this hump and this hump are not the same. Oh my goodness, let me come back and reassess myself, because I assume that hump and that hump were the same, but that one is preceded by kind of a medium hump there. So let's change my window here, and let's change my x min to a 0, my x max back to a 32, and then I'll graph this. Oh, interesting. I do not see here. Let me change my window again. Let's change the x min to like a -10 so I can actually see what's going on here. Okay, so I'm noticing here, I should screenshot this one as well, because this one is the one that really has the answer, doesn't it? Let's go ahead and screenshot you. We'll copy and hit done. Delete screenshot and paste it back in here. So essentially what I'm seeing is that these were not the same shapes, but I'm looking for which of these shapes are the same. And I'm saying, okay, double hump and double hump are the same, which means this one and this one should be the same. And they do appear to be the same. So let's go ahead and see, what is the distance between here and here? Because those seem to be similar features. Well, this x coordinate is about, I'm going to say, can I go to white so I can actually draw on the black? I'm going to say that is about, this spot is about -9-ish. And this spot right here is about 20, I want to say that's like 23-ish. So I'll say that this height right here is 23. So what's the difference between 23 and 9? Well, that's 34-ish. And 34-ish is not an answer. It should be 32-ish. I can't do subtraction in my head. So 23 minus a -9 is really 23 plus 9, and 23 plus 9 is 32. And this number is really close to 32. So I was wrong, my first guess. Once I did my further analysis, I think I got it. It should have been A, 31.416. All right, and number 3, we have an equation in here. Oh, interesting. So it kind of tells me what to plug in. And the problem is I don't know K. So here's my roadmap of how I'm going to solve this one. I'm going to plug in 5 into T. I'm going to plug in 21.3 as my output, and that will leave numbers, except for K, and I'll solve for K. Once I get the value of K, then I'll have the real equation, and then I can just plug in 3 into the real equation. So let's go ahead and do that. Here's me writing down my work. I have R of T is now 21.3. So I can say 21.3 is equal to my 8.4 natural log of all of this stuff. It's going to be 1.7 times T, which is, in this case, we're plugging in 5 to get this output of 21.3. So I have to plug in a 5 again. And then I'm going to add K. All right, so 17 times 5 is 85, so this is going to be 8.5. So this is really going to be natural log of 8.5 plus K. And I want to get rid of this 8.4. So really what I'm doing here, let me show some more work. I didn't mean to grab you. Let's grab that. There we go. So I'm going to say I'm really dividing both sides by 8.4, dividing both sides by 8.4. That doesn't look yummy. That's why we have a calculator. So I'm going to second mode to quit out of this. What is 21.3 divided by 8.4? Yummy, yeah. So it's that number, which I'm just going to do 3 decimal places for now. I'm just going to say that's 2.536 is equal to all of this. So how do we undo a logarithm, a natural logarithm? Well, a natural logarithm is log base e, and the way that we undo logarithms is we look at that base and we exponentiate with that base. Since it's base e, I'm going to say everything here is really e to the power of natural logarithm of all that stuff. And if I exponentiate the right side, I need to exponentiate the left side, and I can say it's e to the power of 2.536. And technically those equal to signs can move down a little bit to say, okay, I'm really talking about these bases now. So when we do this e and this natural logarithm cancel out, and I'm just left with 8.5 plus K. This left-hand side is a number that I definitely can't do in my head, so it's going to be e to the power of, I'm just going to hit second negative sign, so e to the power of answer is equal to 12.625. 12.625. And then from there, we just need to subtract 8.5, so minus, if I hit minus 8.5, it says answer minus 8.25 is this number, which is 4.125, and that's value of K. So now I have a complete equation. I can say, hey, this K right here is 4.125. And I can now plug in 3, because it was after, what is 3 when I plug into the real equation? Well, I can say R of 3 now is equal to, I can fill in the full formula, 8.4 times natural log of my 1.7, and then I'm plugging in 3 now, plus the value of k, which I just figured out was 4.125. And you can store on your calculator if you want to be like super accurate. I'll show you how to do that. So you hit the store in the bottom left, and then you can choose whatever variable. If I want variable A, I hit alpha math to do variable A, and now variable A stores that number. So if I hit alpha A again and hit enter, it's like, oh yeah, that's still holding that number. So I don't think you need to, because logarithms are not very discriminating against decimal places, as opposed to like exponentials. Those are the vice versa. You really want to make sure you have accurate decimal places. So I'm just going to do it the way most students would, and I'm just going to type this in with this rounded, and it's probably going to be closest to the right answer. So I'm going to type in 8.4 times the natural log of 1.7 times 3 plus 4.125 and the parentheses, and we get 18.664. 18.664. You can see, oh, okay, we got a little bit of rounding error because we rounded right there, but that's the reason we're off a little bit, but that's clearly going to be option C. Excellent. Well, that does conclude our 3-peat E activity. Thanks for watching.